We want to look now at algebraic combinations of functions here. So we want to take old functions, combine them, and get new functions. So let's consider an f of x here that's 1 over 1 minus x, and a g of x that's square root of 1 minus absolute x. So we want to ask, what are the domains of those functions? So what are the x values that make sense? So here, this is a rational function, so we can't have the denominator equaling 0. So for f here, we can't have the 1 minus x equals 0. Bring the x over so we get x equal 1. So we can't have x equal 1. So that means that our domain of f is going to be in intervals. We could do negative infinity to 1 union 1 to infinity. Or if you want, that's the same as the set of all the x values that are not equal to 1. What about our g here? Well, we got a square root in there, and you cannot have a negative under the square root. So for g, we need what's under that square root, the 1 minus absolute x. We need that to be greater than or equal 0. So bring the negative absolute x over as a positive. So 1's got to be greater than absolute x. Remember, that's the same as absolute x less than or equal 1. And an absolute value less than inequality translates to a between. So x is between 1 and negative 1. So that's going to be the closed interval negative 1 to 1. And that's our domain of g. Okay. So then the function f plus g at x, you just take f of x and you add g of x. So this is just going to be 1 over 1 minus x, and then you'll add on that root 1 minus absolute x. And the domain here is going to be the intersection of these two domains. So it's going to be everything in negative 1, 1 that's not equal to 1. F minus g at x, so you're going to do f of x minus g of x. So this will be the 1 over 1 minus x, and then we'll subtract the root 1 minus absolute x. So it's what you would think. F times g at x, you're going to multiply the two functions. So you're going to do 1 over 1 minus x times your root 1 minus absolute x. And this is really on the top, that's really over 1. So you could multiply straight across and get root 1 minus absolute x over 1 minus x. And again, the domain is going to be the intersection of these two. And then f divided by g of x, so we're going to take that 1 over 1 minus x. We are going to divide by the root 1 minus absolute x, which is over 1. So if you invert and multiply, that's 1 over 1 minus x times 1 over root 1 minus absolute x. And you can multiply straight across, and you'll get 1 minus x times root 1 minus absolute x, all in the denominator. Now this domain's a little bit different here. We can't have x equal 1, and then we can't have absolute x equal 1. So we have to kick out the 1 and the negative 1 here in the domain. So this domain of f divided by g is actually going to be, so we're going to include negative 1 to 1. We've got to kick out the 1 because it makes the denominator 0 here. And then we also got to kick out the negative 1. So we can't have the ends, either of the ends there. So this is just going to be negative 1 comma 1 open. And then all of these guys here, you're just going to intersect the domain. So you're inside negative 1 to 1, but you can't equal 1. So here, all the domains are going to equal, let's see, we can have the -1, but we can't have the 1. So -1, comma 1, parenthesis at the 1. And then f cubed of x is the same as f of x quantity cubed is what that means. So you're going to take our f of x, 1 over 1 minus x, and that guy gets cubed, which means take the 1 minus x in the denominator and cube it, because you cube the numerator and denominator, but 1 cubed is just 1, right? And then the domain of f cubed here is the same as the domain of f, right? The only restriction is you can't have 1 in the denominator. So this is going to be set of x not equal 1. Or if you want to do intervals, you can do this. So that's combinations of functions, arithmetic combinations of functions.